Hello, everyone. Again, we are approaching the end of the day for the DevOps Pro. I say a couple of minutes ago that in 10 minutes we will be back. It was sooner. I was having some issues with the schedule today. Honestly, between the time zone change and everything, it's a little bit complicated for me. Anyways, probably I need some coffee eventually. Next session, we are going to be with Shahmeer Amir. Apologies again. I'm usually pronouncing it in a very bad way, so apologies for that. He's a world-renowned ethical hacker, and it's the third most accomplished bug hunter. So be careful with him, because if you doing some bug, he can probably hunt it and chase it and completely squash it. He's the CEO of Unit. So welcome, Shahmeer, on stage. Apologies again if I'm pronouncing your name in a wrong way.
Thank you so much. It's a pleasure to be here, and I hope that I don't disappoint the audience with the amazing introduction that you just gave.
Well, I put the bar a little bit high, right? It's a little bit higher, anyways.
Exactly. So I'm hoping not to disappoint. That's basically it.
Yeah, we are not going to talk about bug hunting, but I'm gonna leave you the stage for you, and so you can start the presentation whenever you want. Okay.
Okay. Hello, everyone. First of all, welcome you all to this amazing session, this amazing talk that we're going to have today. It's about breaking barriers, bypassing next generation 2FA and MFA implementations. As the host said, my name is Shahmeer Ahmed, and I am going to be talking to you about this particular session today, and hopefully not disappoint you with it. So I hope that it is visible to all of you. Let me just full screen it. Yeah. Okay. Yes. Here's a little bit introduction about myself. I am Shahmeer Ahmed, and I have been recognized as the third best bug bounty hunter globally. I have been in this field for the past lots of years actually, and I have been doing bug bounty hunting for the past 7 years. Right now, I'm basically leading my own consultancy company and doing multiple startups at the same time. Okay, so agenda for today is, we are going to talk about 2FA, how it evolved over the years. We're going to talk about implementation of 2FA and MFA. We are going to bypass 2FA in web and mobile applications. We're going to bypass MFA using logical flaws. And then, we're going to just see if we have time left to do all of the other things. Okay, so let's talk about 2FA. 2FA, two-factor authentication, is basically an identity and access management security method. Basically, someone thought of 2FA, I don't know who it was, but they thought of 2FA as a security measure to implement, to solve the problems when it came to passwords. Because passwords are non-rotatable, they're tied to user accounts, and we needed to have a system in place that could replace passwords. So that's why 2FA was created. And then someone else thought about the idea. Okay, these tokens can be tied to hardware and user biometrics, because at the end of the day, it's the token itself, right? So then they created MFA. But 2FA and MFA are similar in a way that behind every authentication mechanism there is a token, and that token is what drives it forward. The working architecture of 2FA is in 4 processes or 4 steps. We have the application authentication, we have the login, we have the OTP generation, we have the OTP delivery. basically all kinds of 2FA mechanisms can be, devised into these aspects actually. Going down the line, we have 2FA and MFA implementations. So all of the 2FA and MFA implementations that you see online, all of them basically can be summarized into the following methods that you see on screen. All of them can be, compressed into the following methods. We have SMS, we have the user biometrics, we have the time-based thingy, the push notifications, the challenge, the email, the FIDO UTF. Every 2FA and MFA implementation can be summarized into this. And every bypass of 2FA and 2FA in web and mobile apps can be collectively summarized into these 10 methods. 2FA will be either brute force, there will be a session flaw, it'll be compromised using CSRF, there will be a code reusability function, the request method problem, the response code manipulation, the input parameter manipulation. 2FA code will be leaked, there will be OAuth bypasses, or either there will be forced browsing. So let's look at the first one, brute force. Brute force, we know what it is, right? It is basically a common type of attack that relies on the guessing game. Like we have to guess the path, we have to guess the right code. 2FA methods that are not time-based or victims to these attacks. Before we move forward, let me just tell you how we are going to go about with this. I'm going to explain an attack, and then I'm going to explain the relevant examples or the relevant case studies that were present with that attack. So, for example, we are going to we explain what brute force is. Maybe we already know. Then I'm going to show you an example, and this example is of grab. We know what grab is, right? We know what it is. We have seen grab before. We have used grab before. We know what it basically is. It is a company that is a ride-hailing app that works basically in Malaysia, and what you see on your screen right now is what happened in Grab. Basically, their 2FA code was being leaked. The 2FA code was being brute force, and we had to check the content length of the responses to differentiate which was right or which was wrong. The parameter was called. The parameter was basically called profile activation code, and if we brute force the grab per this particular parameter, the wrong tries would result in a 617 response, and the correct one resulted in a 2250. And that is how we basically came to know that grab had this particular problem. Now moving forward, Slack was also a victim of this kind of attack. Basically, we had a similar problem in Slack once, and the issue was that Slack had it was a password reset token, and the user requested a password reset token. They visited the password reset page, and then they would get redirected to the 2FA endpoint. But the problem was that there was no rate limitation on the 2FA endpoint after the password reset token. And this was very ironic, by the way. Dashlane. It's ironic because Dashlane is a password vault, and password vaults are usually supposed to keep our passwords safe, right? But it was very ironic because Dashlane was vulnerable to a brute force bypass in their 2FA code. So this was by the use of headers, actually. And what happened was that X forwarded for or X forwarded host headers are basically used to do a couple of things, including but not limited to specify the origin of a particular request. And this is what happened in this particular case as well. When we were brute forcing the 2FA, it was, the origin of the request was not stated. And because the origin of the request was not stated, there was a problem. And the server thought that the request is basically coming from itself, and it did not, stop it. And another very, very interesting case study that we identified, this was in Microsoft, and this is very interesting. This was not 2FA. This was not only related to 2FA, but it resulted in a complete account takeover. This is the gist of it, but Microsoft uses 2FA for login purposes, for payments, almost for everything. And what Microsoft did was, there were two problems in this particular case. Microsoft was not verifying the reality of the IP address, and Microsoft was not verifying the number of concurrent requests at a particular time. So what we had to do was, we had to very simply and fairly come up with a scenario where we could generate concurrent requests for the same account at the same time from all those IP addresses. So what happened was that we had the 2FA code consisted of 11 million possibilities. So we generated a list of 11 million fake dummy IP addresses. We created a script that would, spoof the origin IP address and send 11 million such requests at the same time. And combining both of these vulnerabilities, it worked. We were able to successfully, hack into a Microsoft account using this particular vulnerability or flaw. Okay, next, broken session management. This is basically a typical, non-typical different scenario. Broken session management or authentication is a flaw where the login sessions are not properly handled, or the login session management is weak. And the first scenario that we listed this in, or identified this in, was in Facebook. Facebook was basically passing the user ID and the nonce-cookie ID in the URL parameter itself. And this was in the donate option. So if you would click that, donate from any organization, you were redirected to an endpoint. And if you copied that link and you used it from another device, you would log into that particular account that clicked on the donate link. So this bypasses all authentication measures and 2FA measures simultaneously. So this was very interesting. Next came in Mapbox. Mapbox is an online mapping API that is basically used, and this was a problem in Mapbox that Mapbox basically redirected you to Mapbox basically redirected you to your internal session after the password was reset. But if you had 2FA enabled, Mapbox did not ask you for a 2FA code after the password reset took place. So this was a very fine, peculiar example that we identified in Mapbox. Moving forward, this was very interesting, and I think that these probably these videos are going to be available and you will be able to see it because I think the streaming speed is perfect. But in this particular case, we bypassed Instagram's iOS 2FA, and this was because of this particular problem. I don't know if you can clearly see it or not, but it was a problem in the secure here configuration system. So I have a video of this and I'm going to show you to you. It's in the slides. It's probably visible to all of you. This is between a victim and an attacker. The attacker is requested an email change on behalf of the victim, and the victim has basically declined that request, and the attacker is going to get a notification regarding that. And this particular system is basically abusing that particular functionality. So I think that this is a very interesting concept, and I think that this is a very interesting scenario that we have to deal with. So yeah, I think we're gonna move forward with it. Just gonna turn off my video so it is we get a better reception. And you are shortly going to see that the victim account has been taken over successfully. I hope this was an interesting demo. See? Anyway, let's move forward. Now we're going to talk about CSRF. CSRF is basically a scenario where you either disable the 2FA of a particular account, or you either use a scenario where you are able to successfully change the user's 2FA phone number. So, and this was another very amazing, great example that we had in a website called MailRU. And what happened was that MailRU basically had a problem in one of its partner websites called pandow.ru, which was that it was not having any CSRF token on its 2FA page. So what potentially could happen was that an attacker would craft a page, a specific page, and that specific page, what it would do was that, it would force the user to disable their 2FA. And this was what was happening with pandow.ru. Then we have something called code reusability. Now, what code reusability does is, in this particular case, would be that it allows an attacker to use a previously used 2FA code. This was a problem in WordPress, actually. And this particular problem was that WordPress.com was allowing old 2FA code. So if I have a 2FA code that I acquired when I was activating 2FA, I can use that 2FA code as many times as I want to, and no other 2FA code would be usable. Then there was a problem in the 2FA. Then there's a scenario where the 2FA codes are actually being leaked. And now this is very interesting because this comes in one or two forms. Either the 2FA code is being leaked in the request or the responses, or it is being leaked in the application source, or somehow in the algorithm itself. This was another very interesting case study, or a very interesting scenario where the 2FA code was being generated on the client side itself. So when you would request a 2FA code, it would generate it on the client side, store it on the server, and then compare the generated code. So essentially, you were getting the code that you were generating from your own side. And yeah, and then there's this. This is also very, very interesting, and one of my favorite 2FA bypasses, by the way. You must have seen you must have seen the QR code that basically comes in when you are basically requesting to activate your 2FA, right? That QR code is based on a secret key, and that secret key is basically the entire reason behind your 2FA implementation. And if somehow someone would get access to that secret key, they could disable your 2FA or attach their own account to your 2FA, and you're basically a goner. And we faced a similar issue. So this was basically a team management app that we had, and this app, what it did was it basically allowed the non-admin user to view secret keys of other team members. So, and we checked it out. We basically, when we checked the Burp Suite request and we sent it to the repeater, the responses contain the 2FA secret key values. And what we could do was we could then take those secret keys, create a QR code out of them, scan them with Authy or Google Authenticator or whatever, and then we would essentially attain access to the entire session. in that particular case. And as you can see in front of your screen, you have the particular disclosure of that secret key, and we could very easily take over user accounts and cause all sorts of mayhem. Then we have something called the input parameter poisoning. Now, there are more than one ways to explain this, but this basically allows an attacker to create an HTTP request that they can essentially, with their own specified or values of the parameters. So something like this, actually. If and this was in Glassdoor. We all know what Glassdoor is, the biggest HR classified on the internet. In simple terms, if you sent a blank code or if you sent a null byte, you could essentially bypass Glassdoor's 2FA. Not in the original request, but by intercepting that request and then removing the code itself, you could very easily bypass Glassdoor's 2FA. And same thing was in PayPal. And this was also a very, very highly interesting scenario in PayPal that, when you go to PayPal's login function and you go to the alternative option, which is the secret question and also that sort of stuff, and you intercept the request of those answers and you remove the challenge and response fields, the backend application does not verify that. And this allows you to take over potentially any user account on the internet. This allows you to take over essentially all user accounts that PayPal has, and this allows you to potentially cause this was rewarded by PayPal, and we when we identified that, PayPal actually took it very seriously and resolved this. So this was a very big vulnerability. Okay, this is also very interesting. Response manipulation. We have request manipulation and then we have response manipulation. Response manipulation is the activity of changing the responses that you get from the server and forcing that response back to the server. I have a very awesome example for this that I'm going to show down the line. This is the simplest version of it, but the awesome example is about basically an account with a 2FA. A valid 2FA would get you in JSON a true response, and an invalid 2FA would basically get you a false response. Now, in this particular case, you can change that response back to true, and what you can do is, after changing that response back to true, you can force the server to accept that response, and once the server accepts that response, you can fairly easily bypass the 2FA. Take it a bit further. The next step would be for the server to accept that particular response, and what would you do? You would then, the server would ask you the cookie or the authorization bearer, and then you provide that, and you can bypass that as well with the response manipulation technique. This is another very amazing and awesome example. You enter the victim's ID and password, and you intercept the request, copy the MFA value, and you, again, after the OTP, you paste that MFA value saved from the response, and by simultaneously changing the previous values with the stolen one, you can bypass 2FA as well. Okay, one of my favorite examples of this entire session is this. So this was a problem in one of the e-wallets in Finja, actually, that we had. And that particular problem was that we were that Finja was not basically verifying responses. So they had 6 different authentication mechanisms, and they were sending requests and responses from the server encrypted. Like even after SSL encryption, they were encrypting responses with a secret key within the app itself. And so we had to identify first the decryption mechanism and then the correct response. So what we did was we dug into the application and we found out the encryption key that was stored in the application. Then we decrypted the responses that we decrypted all of the responses that were positive, and we interchanged the values for specific user accounts with those positive responses. And you're going to see in the next video, in which I'm going to probably keep quiet, that how it really happened. But we bypassed 4 steps of authentication by chaining 2 vulnerabilities: the disclosure of the encryption key, and second, the response manipulation. So we basically bypassed 2FA using 2 of these vulnerabilities. So and please enjoy this video that you're going to see in the next slide. It is a very amazing video, and I have done my best to explain as much as I could. So a little bit of commentary, guys. By now you must have known or identified, all of the possible outcomes of that particular case and of that particular scenario. So as you can see, everything bypassed, everything done, and now the application is going to crash. But we have all of the required data. We have taken over the user account, and this way we were successfully able to take over all user accounts that were identified. I've gotten a note that we have 10 minutes left. Very sad though. I was hoping we could have, I could riffle through easily, but this is another example, guys, that I wanted to show you. I'm sorry about the sound. This was something called Shapeshift. Now, Shapeshift is a very interesting application that allows you to convert cryptocurrency, and we had the same response code manipulation in StuFA, you know, and we could essentially manipulate the response codes and take over any user's account via 2FA. So this was by one of my friends called Ivan Ricafort, and we were it was his research originally, and we combined it. So moving forward, we had again the response codes were being manipulated, and that's why we were very successfully able to bypass 2FA. And I'm gonna riffle through quickly because I want to cover most of it. Then we have something called random backup codes. Now, in our research, we have identified that 3 out of 10 apps do not implement client-side checks when it comes to backup codes. So you can essentially manipulate the request using input parameter manipulation, remove all the backup codes from that particular request, and then forward that request and it would get accepted. 3 out of 10 apps do it. And it works something like this. This was another unknown site. We enabled 2FA in a website. We knocked down the backup codes. And after entering the email password, we went to the recover option and used backup code option. And we entered random backup codes or zeros. And to our surprise, that was accepted. And it was an eye-opening fact that in our research, 3 out of 10 apps basically do it. So yeah, this is another very interesting scenario, and I think this would be the last one that I would cover. There are multiple request methods: get, head, put, post, catch, and delete. In my research, I identified that if you hit a 2FA or MFA API and you use the delete method, the delete method disables 2FA completely, and that happens a lot too. And this is another very interesting method of bypassing 2FA. If you have social logins, make sure you implement 2FA on all of those social logins because hold on, this because this is called Relate IQ. It is now known as Salesforce IQ, and uh, what happened was that the social logins did not have 2FAs in their mechanism, authentication mechanism. So if you clicked on any one of these links, you would not be asked for a 2FA code. Let's riffle through this, skip this, probably skip this. Interesting though. Let's talk about bypassing MFA. Uh, and I'm going to give you a very brief walkthrough in this, and we can probably cover it all next time or an in-person talk when I come to CyberWiseCon next year. But this is also a very interesting thing. MFA can essentially be bypassed using these 7 methods. And these 7 methods are phishing kits, legacy protocols, fatigue attacks, voicemail, SIM swapping, MIT, and wireless guest network. MFA is a broader thing. It is used in places where in enterprises, in multiple other places where there's a requirement of hardware tokens or user biometrics or stuff like that. So MFA can essentially be bypassed using all of these scenarios. Now, a quick walkthrough would be phishing kits are now using VNC protocols. They're not using web browsers. Legacy protocols are IMAP and all of that's, POP3 and that stuff that do not have 2FA in their architecture. So if you can force an enterprise or an Active Directory to authenticate using legacy protocols, that is also a very, awesome scenario. Fatigue attacks. This was something that was done by that Uber was compromised with. That attacker was basically sending in a lot of 2FA login requests, and the victim just had to identify that. Then we have voicemail. Now, if the user is busy on a call, the call is sent to voicemail, and there are options where you can request a 2FA code using call. And if somehow you can force that code to a voicemail and extract that information from that voicemail, you would essentially be able to bypass 2FA. Then we have something called SIM swapping, which is a very in scenario in MFA. SIM swapping basically refers to a scenario where you are able to clone the user's SIM onto your own system. Then we have MITM based phishing. And wireless guest network. So I think we are just about done with time. So I'm just going to show you what was left and riffle through the end of the stuff. What we have done is we have sort of, my research is based on 2FA and MFA for a lot of years now, and we've culminated that into a single solution. But at the same time, I would, just like to tell you all that if you have any further questions about the presentation, you can reach out to me over LinkedIn, or my name is Shahmeer Ahmed. You can search me there, or you can email me, and I would be more than happy to answer them. But yeah, we are just about done with time, and I think that if we have any questions from the audience, I would be more than happy to, take them. But I hope that was interesting, and I hope that this presentation was an eye-opener for you, not to rely on passwords or 2FAs, to do your own research, whether you are doing bug bounty hunting or whether you are doing, your personal research. You should have your own perspective on it. And hopefully next year I will be able to give a very broader and in-depth talk about this going forward. But yeah, that's about it for me.
Yeah, that's it. Thanks a lot, Shahmeer. Super interesting. Looks like we cannot trust 2FA anymore. But I'm checking if there's any questions at the moment. We are running completely out of time. Actually, we have, according to this, we are running out of time. Thanks again for participating. I hope to see you in further editions of DevOps Pro. And for the people that are still watching, we are going to be back in 5 minutes for the next session. So stay tuned and see you in a couple of minutes. Thanks. Bye-bye.
Bye, guys. Take care. See you all next year.